50,001, or should you put in 50,000 here? They put in 50,000, right? Okay? But basically they're going to be very, very close anyway. Okay, then we can also talk about marginal revenue and marginal profit. A revenue or profit function specifies the total revenue or profit P as a function of the number of items X. So we can do the same thing for marginal revenue and marginal profit. So what does that mean, the same thing? It means you can take the derivative of revenue to get marginal revenue and the derivative of profit to get marginal profit. What is that? How do we interpret that? What is the meaning of marginal revenue, for example? How much additional revenue you get from selling one more good. Okay, and also what is marginal profit? Yeah, but I mean, just what does the marginal in front of the profit mean? Yeah, the additional profit you get from selling one more item. Right? Does everyone agree with that? Okay. That's what they say here. Sale of one more item. Okay, now, this we didn't do. We should have done this. So, average cost. What's the difference between, or can you imagine, what's the difference between average cost and marginal cost? So we already discussed marginal cost, right? That's the cost of one more. But suppose I said, suppose you make music players, and you made 100, and each one costs a little different to make, right? That's the idea, right? Each one costs a little bit different to make, right? But suppose I asked you, what was the average cost for those 100? What would you do? What? Yeah, you'd sum up all those marginal costs and then divide by the total number, by 100, right? Okay, that's one way to do it, and that certainly makes sense. And there's another way to do it also, though, because we have the total cost function. So what could you do with that? What does the total cost function tell you? Like, if I put in 50 into the total cost function, what's it going to tell you? Total cost of making 50, right? So if I put in 100, then what's that going to tell you? The total cost of 100, right? So then what can you do to get the average cost? Just divide the total cost by 100, right? So more generally, instead of dividing by 100, we divide by x, right? If we just take the total cost function and we divide it by x, that gives you the average cost, right? Okay. So here, suppose that the cost in dollars to manufacture portable music players is given by this. So this is the total cost, right? So what's the average cost? Find the average cost per music player if 50,000 music players are manufactured. So what do? You put 50,000 into this, and then you divide by 50,000, right? Right? Or generally, you just take this function and divide by x, that gives you the average cost function. Right? Okay? So find a formula for the average cost function. Okay, and we'll call it this. C with a bar on top will be the average cost function. So what is the formula? We already know it. It's just this divided by x, which means what? There's an x divided, this term will be divided by x, this will just be 20, and this will be just x, not x squared, right? And that will be the average cost function. So anyway, to do it specifically for 50,000, we put in 50,000, so that's the total cost of 50,000, which turned out to be that, $900,000, and then we have to divide that by 50,000, or whatever, yeah, 50,000. So we do take that divided by that, which is, do they tell us what it is? $18 per music player. Now, we found that okay, let's note one more thing. We found that the marginal cost of 50,000 was what? Do you remember what that number was? Just a few slides ago? It was 10, right? The marginal cost was 10. for the 50,000th player, right? But the average cost is what? Is 18. Okay, why is that? Well, yeah, it was the total cost wasn't decreasing, but what do they call that? Economies of scale. Economies of scale. What does that mean? Economies of scale. That means if you produce more things, usually it costs less per item, right? Because you can spread out your costs, like with your fixed costs. You know, like your factory, you have to pay the rent. Whether you build one or you build 50,000, you still have to pay the same rent, right? So you can spread out that cost of the rent. Okay, so it's less per item, right? So when we produce 50,000th one, the cost is not so much per item, but down at the beginning, the cost is higher, more than $18. Maybe it was $30 per item, okay? For the first item, or the second item, or the third item. Okay, but this gives us the average for that 50,000. Okay? All right? And here's the formula that we decided was the correct formula for the average cost function. Right? C of x over x. So we get this, the average cost function. Okay? The average cost is different than the marginal cost, right? Not the same thing, right? This is the average cost. That's probably not equal to C prime. Okay? In fact, anyway, no, not the same. All right? Okay, so that was that. Let's see if we missed anything here. Okay, we did this, right? Everybody remember this? What is this called? Product rule. That's if you have, so let's just quickly review. If you have the product of two functions and you want their derivative, you use this rule. So for example, here's one function times another. So you could say it's the derivative of this is 2x times just this, plus the derivative of this is 3 times that. Okay, that's the product rule. Okay, that was a quick review. Okay, let's go to this one. What's this? The chain rule. Let's review that quickly. So what is the derivative of this function? Or this function here? So you have to use what rule? What rule do we need? What? No, not the power rule. Well, what's the name of this slide? Chain rule. So what rule do you have to use? The chain rule. And what that means, usually we're thinking that there's an outside function and an inside function. So what would we say is the outside function here? Raising something to the half power. And what would we say is the inside function? 3x plus 1. So with that observation, then we can use the derivative. Okay, let's see, how do I do this? So here's one form of the chain rule. This actually, we never wrote it this way, but it's the derivative of the outside function evaluated at the inside function times the derivative of the inside function. So, let's see. Okay. Let's try, see if they give us an example. Okay, how about this one? So, again, what rule are we going to have to use? chain rule, so we have to see that there's an outside function. Let's do this one. We have to see that there's an outside function and an inside function. So what's the outside function? Raising something to the 100th power. And what's the inside function? X cubed plus x, right? So the chain rule is going to say take the derivative of the outside, which is what? 100 something to the 99th power, right? Maybe I doubt that this will work, but I'll try it. 100, no. 100, no. Doesn't work. Okay, that worked. 100 to the, no. No. 90, no, doesn't work. Okay, 100 something to the 99th power times what? Over here, times what? The derivative of the inside, which is the derivative of that, which is 3x squared plus 1. Okay? So that's the chain rule in action. Okay? Okay, so that was the chain rule, so that was a quick review about the chain rule. Then, what about this one? I think they are there, but that you have access to them in the resources. If you don't, you can tell me. Okay, now let's talk about the log function. So you see here ln of x, right? Everyone see that? Just this part here. Yeah. Just here. Okay? ln of x. Okay? Now that is related to the exponential function. We talked about it. So, how is it related? It's related in the same way that these two functions are related. X squared and the square root of x. How are they related? If you do one of them and then you do the other, you get x back, right? Right? And these are also related in this, like this. Visually, they're related because x squared looks like that, right? And the square root of x looks like that, right? And in terms of their pictures, they are mirror images through this line, right? We talked about this, right? Okay, so one is that they're visually related, and the other way that they're related is if you do one, square something, and then take its square root, it's like you did nothing. And this relationship, when functions have this relationship, we call them inverses. So inverses, what does it mean? If this is f, and this is g, what does it mean? It means that f of g is just equal to x. Right? If you do one and the other, you just get x. So often we write, instead of writing g, to indicate that g is the inverse, we write that. That means that f and g are inverses. Okay? And that means specifically that if you do f and then you do this, you just get x. Okay, that's what inverse is. That's what when we write f with that little 1 there, that means that it's related to f in this way. Okay? And visually they're related like this. So, going now to going now to f of x equals e to the x, right? We know about that. We know that the picture of that looks like this, and this is 1, right? Because e of 0 equals 1, right? So e of 0 equals 1, right? And it looks like that. Now that g, if we talk about ln of x, let's call it g, is ln of x. Okay, that turns out to be the inverse of e to the x. So visually, what does that mean? That means if we draw this line, the ln function will be where? Will be the mirror image of the e to the x function. So that means if this is 1, then this will be 1. Okay? And it looks like this. Okay, so that's the ln function here. Okay? And also it means what? It means that if I do this and then I do this, I get nothing. I get just x back, right? So let's say that. If I do ln, you can do it either way. So let's say I do ln first, and then of e to the x, I should get what? X. And then I can write it the other way. If I do e to the ln of x, I also should get x. Right? Okay, so that's what the ln function is. Okay, but we also know that the ln function is also the log base e of x, right? That's ln means the log base e of x, right? And we also talk about other bases. For example, the log base 10 of x. And you know how that works, right? So if I ask you, what's the log base 10 of 1,000, right? That means what number do you have to raise 10 to? What exponent do you have to put on 10 to get 1,000? So 10 to the what equals 1,000. That's what this will go here. So what's the answer? 3, right? So we say the log base 10 of 1,000 is 3, because 10 to the 3 equals 1,000. Right? So then we can also say that the log base e of let me put e cubed equals, so e cubed is a number, right? Right? E is a number, so e cubed is a number, right? So what is that? What do I have to raise e to get e cubed? 3, right? Okay, so that's 3. Okay? Now, okay, so what about this? The log base e of e says what? What do I have to raise e to get e? 1, right? So that is 1, right? So what we're saying, but we can rewrite that as ln of e equals 1, because this means this, right? I mean the same thing. So ln of e equals 1, right? And how about this? Let's rewrite this. Log base e of e to the x means what? Means what do I have to raise e to to get e to the x, right? Which is what we said. We said that they're inverses, right? And here we see, of course, that that's true, right? Okay? So anyway, ln and e to the x are inverses. Okay? And you can see that from here, right? All right? So now how about ln, yeah. Okay, so that was a quick review of the ln function, right? So now you know about the ln function, which is right here. The question is, what is the derivative? What is the slope here, for example? What is the slope here, for example? Right? That's what this class is about, right? We're trying to find slopes. So we want to be able to know that. So we want to know the derivative of the ln function. Okay, so here it tells us what the answer is. And actually on this slide, I think they actually prove, on this set of slides, they actually prove this answer. But right now, let's just concentrate on what the answer is. So what is the answer for the derivative of ln? Okay, it's 1 over x. All right, so you know the formula, you know the derivative of e to the x is what? E to the x, okay? And now you're also supposed to know this. The derivative of ln of x is, you have to remember it, it's 1 over x. Okay, or you can